Hey y'all, welcome back. It's Mr. Boyden, your personal math teacher. I'm back at it again today, and today we're going to be talking about the exterior angle sum theorem. So last time we talked about the interior angles. Now we're going to be talking about the exterior angles. Okay, and so there are two main things we need to understand today. First of all, what is an exterior angle? And then the second thing, is there a pattern that emerges when we add all of the exterior angles up? We're going to start today with the same pictures we had last class. Okay, we're not going to do, I think we had 8 of them or 6 of them last class. We're just going to have these 4 today. That should be plenty for us to notice the pattern. The first thing that I need to show you is what an exterior angle is. I remember when I learned this, I first thought it was all the way around the outside, but it turns out that's not what it's defined as. An exterior angle is the angle that's formed if we extend out these sides. So if I extend and extend, and if I extend. Okay, these are exterior angles. And so the question is, what happens if we add all those up? Well, let's try it. One of the things that might seem weird at first in this lesson, you're like, wait, but what are the sides? Or what are the angles in this shape? So let's look at it. It's a triangle. We know that triangles add to 180. And we saw in the previous video, when you divide that by 3, each angle in here is 60. Okay, so they're all 60. Well, how do we find an exterior angle then? Well, notice that we have a linear pair right here. And so those two have to add to 180. So 180 minus 60 is 120. And since all of these are linear pairs with 60, they're all 120. So, what was the question we were trying to answer again? Let's double check. Is there a pattern that emerges when we add all of the exterior angles? Okay, we need to add up all the exterior angles. So that's 120 plus 120 plus 120. That adds together to be, zeros go to 0, 2 plus 2 plus 2 is 6, and 1 plus 1 plus 1 is 3. That's 360 degrees. That's our first shape. Let's see if there's a pattern that emerges on the next shape. Let's go to the rectangle. We remember that the inside of a rectangle is 90 degrees all the way around. And so now let's extend these out to find those exterior angles. Okay, now y'all, the math is going to be very similar on this, okay? Because what we have, we've got a 90 degree angle here, and we have a linear pair, so the other side is also 90. Okay, like, if that's not clear right now, look at this right here. See how that basically is making a letter T? We know that a letter T has two 90 degree angles, okay, and so that's what's going on here as well. So 90 degrees in that exterior angle and 90 degrees in that exterior angle. Let's add those together. So the exterior angles are 90 on this one, and there are 4 of them, and so that is 360 degrees. Okay, we got the same thing. Interesting. Let's see if that continues, if that works for all shapes, or maybe, you know, sometimes it's just a coincidence. It'll just work for these first 2. Let's go find out if it works for other shapes as well. So scrolling a little bit to the right, let's look at this pentagon. Now, you may need to look back in your notes, because in the video before this one, we learned how many degrees are in each angle of a polygon. And one of the things that we wrote down for a pentagon is that each angle is 108 degrees. That was something that we found in the previous lesson or the previous video. So those are all 108. Let's draw out the lines so we can see the exterior angles. I always think it looks like the shape is spinning when I do this, like it's spinning clockwise for some reason. It always looks really cool. So the exterior angle is here, and all of these are on here as well. And in this case, they're all the same because it's a regular shape. So how do we figure this out? We know that these two angles down here, 108 and the exterior angle, make a linear pair. They have to add to 180. So 180 minus 108 is 72. There are 1, 2, 3, 4, 5 exterior angles. So this is 5 times 72. And what is 5 times 72? Oh, interesting. 360. Okay. So that pattern is held up. That's 3 shapes in a row. 360, 360, 360. Let's do another one. Let's go over to the hexagon now. And we'll do the same thing. In the previous video, we learned that in a hexagon, each interior angle is 120 degrees. So I'm going to put that on here. I'm going to finish this drawing out so the thing looks like it's spinning, because that looks super cool. And let's find that missing angle. 120. Oops, not divide by. So sorry. Minus Haha, that's a silly mistake. 180 minus 120. Sorry about that. I'm getting ahead of myself. And so we get that that's 60. And so are the rest of these. Okay, there's 6 angles. Each one is 60. And what's that? You guessed it. That's 360 as well. So y'all check it out. That's a pretty strong pattern. That we're doing a calculation for a bunch of different shapes and we're getting the same thing over and over and over again. This is not proof that it would always work, but it's evidence that would suggest to us that, yeah, that seems like that's a truth. Okay, that's something that actually does work. So let's formalize that now. This is our key concept of the day. Here it is, and it is the exterior angle sum conjecture. Technically a theorem, but this curriculum calls it a conjecture. Okay, and here it is. For any polygon, any, does not have to be regular, any polygon, the sum of the measures of a set of exterior angles is, we just figured it out. The answer was the same every time, 360 degrees. Guys, you can tell because it's in a highlighted box. This is one of your key things that we need to understand today. So I want to encourage you to pause the video and write this down. Maybe also write it in your own words. It'll be easier to remember and understand later if you do that. So pause the video now and write that. Let's do some examples. Okay, here's the first one. I want to encourage you to actually stop here, draw the picture, and try it. So pause the video, give that a shot, and hit play when you'd like to see how you did. This is a question that sometimes will confuse students because there's not any numbers on the picture. We're trying to find angles, but some people think it's like, wait, we're finding them out of thin air? That's really bizarre. How would we possibly do that? Well, there is one number on the picture. It's down here. It's 90. That one we know. And we don't know much else. But we do know that we have a triangle in which all 3 sides are the same. And if all 3 sides are the same, then all angles are also the same. So that means each of them are 60. So 60, 60, 60. Now, why is that helpful? Well, right here now we have a linear pair. And so we can say that's going to be 180 minus 60 is 120. So y equals 120. You know what? The same thing is going on down here. I don't even need to show the work again. It's a linear pair with 60 and a missing number. So x is also 120. All right, so we found x and y, but how do we find z? Well, let's notice the shape that it's inside. How many sides does that shape have? 1, 2, 3, 4. That's a 4-sided shape. That's a quadrilateral. And we learned last class and last video that any 4-sided shape will have an angle sum of 360 degrees. So, and we know the other 3. So all we have to do is subtract 120 and subtract 120 and subtract 90. And that's why this is 30. So z is 30. Let's try another one. Okay, and here it is. Again, I want to encourage you to pause so that you can draw the picture and try to answer this question for yourself. In order to understand a question like this one, it's really important to understand where are the angles located on the picture. You see how there's nothing written inside of the shape? And this looks very similar, this picture looks very similar to how I was annotating the shapes in the beginning of the lesson. Because notice in each of these cases, the shape is extended outward. These are all the exterior angles. And one thing that I think might be confusing about this is you see how they all have these markings? It looks kind of like they're trying to say these are all the same. They don't mean to say that. This particular publisher, what they do when they want to show an angle marker, they always put a dash across it like that, so that they're marking it in that way. So that's one way of doing it. You may find that your teacher does it differently than this, or you may find that other teachers do it differently than this, because in the old school way, that's what we always learned. Just this one book does it differently. Still, these are all the exterior angles. And so what we learned about the exterior angles is they will add up to 360 degrees. And so we know 1 of them, 2 of them, 3 of them, 4 of them. Hey, we only have 1 missing. So what we need to do is subtract these off from 360, so minus 49, minus 87, minus 72, and minus 67, and let's see what we get. Now, I don't think I'm doing that one in my head, so let's reach for a calculator. And so we get 85 degrees. And there's M. Y'all, that's it for today. Hope you enjoyed the video, and I'll see you next time.